off today working on this walk-in freezer. Now, customer says that it's staying at the defrost way too long, for over an hour. So I'm pretty sure it's the time clock, but there are ways to test that. Everything's running fine. My sight glass is nice and clear, and everything's frozen inside. This is freezer. We're pretty much down the temp downstairs. We're below 0 degrees. The set point on this is -5, so that's why it's still running. So let me just, the electrical panel here already took off the screw. Dangle over the edge of the roof here. So this my control panel. Here's my time clock. Let's see, was set at about 38 minutes. So to test the clock, what we're going to do is we're going to slide this timer back to 2 minutes, and we're going to kick it into defrost. It's not going to immediately pull the contactor out because it has to pump down, but you should hear the compressor tone change. So right there's defrost. You can, I don't know if you can hear the compressor change in tone, and it just kicked out. So we're gonna wait and see how long it takes for that to kick out, and see if it takes 2 minutes or longer. Usually, I mean, there is slop in these a little bit, so I'd be happy if it kicks out within, 4 or 5 minutes or so. We'll see how long it takes. Alright, it's been about 10 minutes or so, and this hasn't kicked out. So I'm gonna manually kick it out. Huh, that's not manually kicking out. That's not kicking out at all. I mean, that's... Well, something's really wrong with it. That should have kicked right out. Let me shut the power off. We'll take this out and check out the back of it, see if there's something mechanically broken with it or what. Okay, so we have our time clock out here. It's kind of hard to do with one hand, but I'm going to click it back into defrost. There's defrost. So my contacts, you can see the ones on the right here are closed. These ones are open. These ones are actually a little burnt. Those are my heaters downstairs. That's probably from having the heaters stuck on. So I'm going to advance the clock a little bit here, and this should kick out, or it's supposed to kick out. And it's not kicking out at all. So the timer itself is mechanically screwed up. The timer trip is it's not tripping. So what is happening is the coil downstairs is staying stuck in defrost. It's heating up, and then the defrost termination switch is pulling in this solenoid coil after it warms up a lot, which, like the guy said, takes over an hour. And then when this pulls in, it'll kick itself out of defrost. It'll advance to the next time, which is 6 hours apart, and it'll keep doing that. So I'm going to change out this clock, and we should be 100%. So the easiest way is, if the wires aren't marked, you can just take the other clock and just go wire by wire, is what I usually do. Or you can just take a picture with your cell phone if you need to. Just make sure the wires go back in the same spot. I can't do it with one hand, so I'm going to have to put the camera down and do it and pop the new one in. The new clock is in there. Sorry about the horrible shots, but this screen's kind of hard to see in the light. It's still in defrost, so what I want to do is check the amperage draw on contacts number 3, because that's my heaters. Those are the ones that were burnt on the other one, or black. So we'll check and see. Let's see what we got here. We're only drawing 7 amps, so we're well within tolerance. So I think that was just from the heaters being stuck on all the time. So now we have this set. Each of these pins is a defrost time. So we have 12, 12, 6, and 6. And for a duration of 36 minutes. So right now it is 11:15, but that's way close to a defrost time. So I'm going to advance it past that one defrost time. Now when I hear turn this, you should hear a click and you should hear a ping, which is a solenoid valve opening up, and see this contactor right here pull in. That hisses the gas, and there that is. Alright, so we'll just advance it as close to the correct time as we can get it. These are never going to keep perfect time because of the fact that it has a termination switch, so if it does get hot, it's going to kick itself out of the frost, which will make these go off time. So now since I'm here, we'll just double check the amperage of that compressor and make sure everything's running okay. I gotta put the camera down to get up there. So we're pulling, again, sorry about the 6.5 amps. There's another power leg. There's a black one right here. Kind of hard to clamp on with one hand. That leg's drawing 8, a little bit higher. That's probably running one leg of the fans downstairs, and this is probably going to match that. Yep. So those two, this one here and this one here, are my two power legs that go downstairs to my fan motors, and then that white wire is just the, which technically shouldn't be white, that should be taped, but it's not. But that is the other power leg. So the service call is complete. Another fun part of the job is being in basements. This is a basement of an old building, and this is my unit here that's not working. It's probably about a good 95 degrees down here at least. It's pretty much, we got rows of condensing units. I do all kinds of refrigeration that are upstairs. In this one room here, which is what that fan is for. They blew a hole out that wall to get rid of some of the heat. It's a nice timber post holding up the building. The 2x4s help. Let's see what's going on with my unit. I'm gonna go back over there and start taking some covers off. Okay, so I took my panel off and just did a preliminary search for power off of my control voltage here, and I'm pretty sure I found my problem. That will be a melted wire nut and an arc. So, first of all, I gotta figure out why that melted. And I gotta figure out where my breakers are, because of course I got like 5 panels and nothing is labeled. Awesome. Alright. So I'm gonna repair that. See if we can get this thing powered up, and see if we got a dead blower motor, or if that's just a fluke accident or something. This was laying pretty much right up against this metal here. So that is the return, so it shouldn't get really that hot. Oh, there's the rest of the wire nut. And melted right through. Unless this was just possible, this was a bad connection here. And the wire itself really isn't crispy critted. It's just the nut itself is melted. So we'll slap our amp probe off of here once we figure out what power is. Okay, I replaced both wire connections. I actually found the breaker. Oh, turn the sucker on and see what happens. Alright, that was a click. What was that relay clicking? I can hear refrigerant. Let's see what we got for amperage. And nothing because the blower's not on yet. Now these have a safety switch right here. The door holds that safety switch in and it will kill power to the entire unit. I just have it rigged with a little piece of wire right here just to hold that in while I have this door panel off. I do have the fan on auto upstairs, so it really should be on by now. Make sure everything's hooked up right. RG, GH, GC, W, common, Y. Looks okay there. I'm gonna run upstairs real quick and click that unit on auto. There, I can jump it out down here actually. Give me a second here. Let me jump out the thermostat for the fan. See if that blower motor powers up. Okay, let's see if I can do this with one hand. All I'm doing here is jumping out my main power, or my 24 volt to my thermostat with the fan terminal here. See if this blower turns on. We'll check the amperage. Blower's on. Amps or so. It's well within spec. Everything else looks okay. Still at 6 amps. It could have been a bad connection. It's possible that that loosened up over time. You go make sure everything's running up on the roof. Actually, I can, the A coil's right here. Now if you can hear that hiss going through, that's the refrigerant. Suction line sweating. That's lukewarm. I don't like that joint, but a little hickey there. Oh, it seemed definitely full of refrigerant. Just want to make sure that this blower kicks on by itself. Could be my issue here. Let me check my thermostat upstairs and see what everything's set for. Okay, we're all set in here. Get everything up and running. What the problem ended up being was the actual thermostat upstairs is broken. If you have the taps for the fan set to auto, it won't switch the fan on when you put it on cooling or heating for whatever reason. But the customer opted to keep the thermostat because everything else on it works perfectly fine, and just keep the fan on all the time. The little selector switch, when you turn it to on, it works perfectly fine. So he elected to do that. I told him that, you know, that the heat exchanger here looks kind of icky. Get some light in there, but he said that he doesn't use the heat on this unit, so this is basically being used as a blower only for the air conditioning. It's like in a little foyer of his shop, so I'm gonna leave everything else as is. I'll double check the amperage one more time here. And the other thing I noticed too is he doesn't have a filter in here, and there is no filtered return upstairs. So I'm going to take the measurement of this. The rack is still there to hold the filter. That's what this bar is. So I'll take the measurements for that, and I have to get him a time clock for one of his other units anyway, so I'll come back, pop a filter in, and give him a new time clock. But other than that, this job is pretty much done. Just double check the amperage real quick here, make sure we're still running where we should be. So by my estimation, you can see these rust marks here. I think that the way this was over in this corner was turned upside down. It was kind of shoved really far back. It's possible that this got a lot of just killed the light on this. It's possible that this got a lot of water in it, and that's what ended up melting it. Because if this unit was running without the fan, then obviously it would have iced up. So I'm thinking that's what happened. Just double check my amperage here. 5.5, and I don't even know if I can find a tag on this unit. Let's see if I can find a tag somewhere around here. Nope. More than likely somewhere in this area here. And he did say that this coil is relatively new within the past 3 years or so. But you can see they didn't use a cased coil. What they did is got a bare A coil and sat that in a piece of ductwork. Which, I mean, it works. I just hate when they do that because now you have no access really to this to see inside this A coil here. But I mean, these lines feel pretty good. This is lukewarm. This is ice cold. It's a relatively cool day today too. It's like 60 degrees out, so in the 60s. So I'll just double check, run up on the roof, double check the pressures. I'm not going to show that, but let's run up on the roof, slap them on the condensing unit, double check the pressures just to make sure I don't get a call back. So that's it. Take my little jumper off here, put all the panels back, and we're on to the next job. We got a cool little project here. We have one of those Charleston units that take those relays I was telling you about. Here's the digital keypad, and that relay is right here. But what we got in this unit is a bad expansion valve, and I found this yesterday. You can see it's all encased in ice. Usually when you get that happening, you have one of two issues. Usually it's either a leak or it's a bad valve. In this case, I know it's a bad valve just because my pressures were way off. So I evacuated the system, recovered all the refrigerant. This coil has already been out before, so I have a sweat connection right here. I'm going to unsweat this and unsweat this. We'll take this whole evaporator out and we'll replace that valve. Now, when you're ever using a torch or unsweating anything around these units, you want to make sure you still have your gauges hooked up and your hand wheels open and your gauges vented, because the oil in this compressor will actually hold refrigerant in no matter how well you evacuate the unit. So you need somewhere for the pressure to bleed if it does build up any pressure as you're brazing it or soldering it. Now you don't want it popping back in your face through these joints. So fortunately I don't have 5 hands, so let me unsolder this and I'll put this on a bench somewhere and I'll show you how it looks. Okay, here's the valve we're replacing. This is the sensing bulb here. This right here is an external, this is the external equalizer right here. Here's the sensing bulb. Now, the valve that I have is one of those, it's basically a mega valve from my supplier. In other words, you give them the specs and they'll change out the body and the pin inside for the correct tonnage and refrigerant. So this one's going to sit like this. Have it being upside down isn't going to make a difference, but it's going to sit like that. So we got a little bit of finagling we got to do with our lines here. I'm going to cut this one, and I'm going to cut this. This one right here, as you can see, somebody's already brazed and fixed a leak here. I'm going to see if I can even that out a little bit, but I'm going to unsweat this one, unbraze it from here, and then I'll set up the new one, and then I'll braze this one joint, and then soft solder and soft solder. That way there. I don't like using a lot of heat around these, so I'm going to try to avoid brazing it in. And Stay-Bright is more than plenty strong for this application. So now, like I said, I don't have 5 hands here, so I can't show me unbrazing this. What I am going to do, I'm going to set up my nitrogen with a purge gas through there. I'm going to unbraze this, slide that off, and I'll get the new one all set up. And before I braze it in, I'll show you how we got the new one set up. And then maybe we'll take this apart and look inside it. See if we can see anything actually physically wrong with it.
Alright, here's the new one in place. I already brazed in this joint here. You can see it's nice and smooth and covered. You can see the heat lines go up and they stop right about here, so most of the heat is concentrated on the fitting and not the valve body. Plus I wrapped this whole body in a wet cloth just to be able to cool it down. So this tube here has to go in the bottom here. I do have a reducing bushing because this is 1/4 inch. And this inlet is 3/8. I do have a reducing bushing for this to go to this 1/4 inch. I'm going to have to lift this up. I'm going to have to kind of bend this pipe in. I'm not going to kink it. I'm just going to put a little bit of a kick in this to get it to fit. This valve here itself is physically longer, and I can replace this piece here, but it's soldered to the suction line right here to use as a heat exchanger. So this actually does two things. It also dissipates heat by cooling off the gas going into the valve, further condensing it, cooling it down. And it'll also, if for any reason you're slugging liquid back to the compressor, it'll boil any liquid refrigerant off coming off the evaporator here. It'll boil that off, so you're not getting liquid directly back to the compressor. So I don't want to kind of mess with that and have to unsolder that and resolder it all back on. So I'm gonna either reuse this. I think I gotta. If it really looks like crap here, what I'll do is I'll cut it and put it in 90. But if I can get it to fit, because this is pretty loose here on this, I gotta lift this up anyway to fit. So I'm gonna get this all bushinged into place, and we're gonna solder this up, and then we'll slide it back in. One thing I did forget to show you is here's my purge line going into my nitrogen tank. You just want a little flow of nitrogen into there. A lot of people solder on fittings to do it. The reason this is just an old gauge hose that's cut down to fit up underneath there. I also have one for large diameter pipes. You know, the plugs that, rubber plugs come in on the back of the lengths of larger tubing. I put a little hole in those and then stick a process tube gauge port in those, and I just shove those in the back of the line when I'm doing larger lines. This line was small enough I could just get my gauge hose in there. The reason why I don't put a fitting on there and screw it in is because if for any reason I'm soldering and I seal off a joint and this nitrogen has nowhere to go, instead of pressurizing the system and blowing out the joint that I just soldered, or I'm in the process of soldering, this hose will just pop right off. So just kind of a little safety issue. Also, I forgot to show you, here's the inlet of the expansion valve. They give you strainers that are in there. Usually you have to take them off to clean them, to clean the valves, and put them back when you're done. Also, whenever you clean those valves, make sure, like if you're cleaning inside here, make sure you have the valve, that tube pointed down, so none of the stuff that you're scraping off goes back in there. So this should go down into here until it clicks into the seat, and then I can just put my line right back in there and solder it up. So I'm going to solder it all up, and I'll show you what it looks like when I'm done. Okay, here's pretty much our finished product here. We brazed this joint here. The only reason why I brazed that is because this copper here was really pitted, and also I had to obviously unbraze the other piece. Now, you see this disaster over here? This is just braze that somebody got glopped on here, and obviously they didn't take the evaporator out to do it, and that's why that's burned. This is solid. I did leak check this before I pulled everything out, and that is solid. This place, we had the contract for this client before. They switched companies because they found a cheaper company than us, and basically that company came in and kind of hacked their way through a few things and screwed up some jobs. So we got the contract back. So this here was not done by us. Like I said before, I have taken this coil out before, and this joint and that coupling in there was taken out by me to fix. I believe I had to fix a leak in this coil before. It was not here. It was in one of the bends. It was like this bend or something like that, if I remember right. But that That definitely wasn't done by me. That joint was done by me. That joint was not. Now, I don't want to heat this up and try to smooth this out because I don't know how good the copper is under this, and I don't want to risk burning through it. So I know it holds pressure, and I'll leave it like that. You know, the client knows about that, and we're just going to leave it as is for now. If it does end up with a leak, we'll kind of cross that bridge when we come to it, but it's holding now. And like I said, that joint there, that joint there are both soft soldered. Now the solder that I use is Harris Stay Bright number 8. It's a silver bearing soft solder. It melts around 500 degrees, but it has a pretty much an equivalent holding pressure brazing rod, and obviously you don't need to use as much heat. You don't need to use nitrogen purge gas, which is really good around expansion valves and stuff because you don't risk overheating the valve. So we'll mount this back up into where it needed to be. Here's the old valve that I had pulled out. I don't know if you can see when they put it in at the factory, they tightened this bulb too much. Get that to focus. You can see the dent in there. So we'll snug that up just enough, and we'll slide this coil back in, and then we'll recoupling it, and I'll clean this up while I have it out before I put it back in. Okay, we're in place. Everything's all mounted. I just gotta get some insulation, put it on that bulb. My vacuum pump's going right now. I put in a new filter dryer. Whenever you open up a system, always replace the dryer. You can see I put in a flared-in dryer. The reason for that is if I ever have to change that, I don't have to bring a torch in here. Kind of got in the habit of doing that on most units because a lot of our clients, we do a lot of office buildings that won't allow torch in the building until after hours. So if I have to change that for any reason, at least I can do it. Recoupling down here, and this on the Trolsons, these are the temperature sensors that they use. The blue one here sits in the coil. This other one here, I need my light to go back on, hang on a second, senses the cabinet temp here. So this goes back in the coil right here. And we'll let it vacuum, and we'll check our micron gauge and make sure we're holding, and then we're ready for charge. So we'll skip the boring part and go right onto the charging for you guys. While we're waiting for that, I broke this old expansion valve down, and I'll show you what killed it. See all that? That's old garbage in the oil. This unit, and it's actually really sticky. This unit, you see inside there too. This unit was never maintained properly. When I came back here for the original service call, the thing was filthy. And especially with 134A, what happens when the compressor overheats itself is, we notice this a lot with, like I said, 134A, which is what this unit is it does something to the oil and turns it very sludgy, but it also pushes it throughout the system. 134A in itself is a solvent, and it'll pick up anything and push it through the system. It kind of sucks as a refrigerant. It's just cheap, that's why people use it, and it was the first alternative to R12 when it came out. We notice a lot more in cap tube systems than expansion valves like this. The cap tube systems, which you'll have, is the capillary tube, which is kind of a diameter of even smaller than that. What it'll do is it'll build up like a waxy substance on the inside of the pipe, and it's like this white kind of chalky stuff, and it just restricts the flow of refrigerant, and you end up having to replace cap tubes or using that special cleaner to clean out the system, clean out the capsule with that. So it's kind of a common problem with 134A. This, like I said, is from the compressor overheating more than likely. The compressor is working, and it really doesn't, I mean, it's moving refrigerant, so this is all sludgy, nasty oil. So we got a new dryer in there, and we got a new, whenever I do the valves, I blow out the coil from both sides, so there's no part, well, as far as liquid oil in the evaporator, I blow it all out just to make sure that there's nothing in it. But the new valve, and obviously I'm not going to be reusing the refrigerant because of it. Whenever I do an expansion valve, even if I recover the refrigerant, I don't reuse that refrigerant just because of the fact that something in that refrigerant more than likely made the valve go bad. You don't want to introduce it back into your system. So what we do is using virgin refrigerant, the coil's clean, new dryer, new valve, so we should be pretty good to go once we get this back up together. Alright, now comes the fun part. We're going to charge. Now we're holding, we're tight, our vacuum's good, and now I know a lot of you are saying, why don't you weigh the charge in? Well, we've done some modifications to the system, so your charge isn't going to be exact. Plus, I can tell you right now, that's a larger dryer than what was originally here, and the reason why is manufacturers tend to undersize their dryers. This had an 032, that's an 052. I just know it did have an 052 on it, but the system has been cut into before. Usually when you look on your dryers, it'll tell you the tonnage right on the dryer, so this tonnage matches the tonnage of the compressor. So your pressure, your refrigerant charge is going to be a little bit off. So I do it by pressures, and like I said, experience, you can get it pretty much dead on. This tank, I weigh it when I take it out of the truck, and I weigh it when I'm done. That way there I know how much refrigerant I put into the unit and what to charge my customer for. So we'll purge our line here. Gets all the air out of the refrigerant line. Put an initial charge in through the high side here. We'll make sure that the low side comes up as we're putting the gas in. We're just putting a little bit of liquid in there. You can see my low side gauge air is starting to creep up. That way we know we're actually going through the expansion valve. We don't have any kinds of clogs or anything. And we'll just dump a little bit in here, and then we'll start it up and we'll fine tune the charge. So what you do is put a little bit of liquid in. Depending on how big the unit is, experience will tell you what your initial charge should be, or about how much you should put in there. And then that there should be good for now. And what we'll do is we'll close that, and we'll let those pressures equalize, make sure that all that liquid refrigerant is boiled off in there, and we're settled. Because what we don't want to do is put a ton of liquid in there and blow all the oil out of the compressor. So we'll let this sit for maybe 5 minutes or so, let it equalize, and let that refrigerant that we just put in there kind of vaporize a little bit, boil it off. And while it's doing that, I'll just take some bubbles real quick and my electronic leak detector and just double check my joints. Everything, like I said, I held a vacuum, but we'll just double check just because, you know, we gotta wait anyway, and best to be doubly sure than get another service call. Alright, my pressures are equal out, so we're ready to plug this in here. There's that digital control. Delay. Error code from the main. Press is running. And we'll see what the pressures do. 134A. It's what, 70 degrees in there, so going to be a little bit higher than normal. This high side pressure should be around 175 usually. Now this is taking into account a 70-degree day, a decent ambient. My pressures before even started putting the valve in were 200 on the high and 0 on the low, so you can see even just with that initial charge we're already better than what we were. So bring this head up, and this low side should be around 20-25 or so for 134A. And like I said, that's what, when you read the gauges, there's your pressure, and depending on the type of gauges you have, these rings are your refrigerant temperatures. Now, like I said, I'd expect this to be more around 175 or so, just because it's hot in the building here and it's warm in the box. Usually condensing temperature you want to be 110 degrees, so normal operating pressure on this, like I said, will be around 150, but we're just hot, and obviously we're low. This should be up here around 20-25. Coil temp should be, for refrigeration, should be around 27 degrees. So we'll just slightly crack our low side here, and you got to remember you're sucking in liquid directly into the compressor, so you have to go slow. And then we'll see this start to climb a little bit. Also, get into the habit of feeling around. Our coil's nice and warm. Our suction line's coming back nice and cold. This was warm last time, and our liquid line going in is lukewarm. So we're definitely pulling some heat. We're just shy of 20. We're a little over 175, but we're still around 60 degrees there. This temperature's reading right next to the coil, so it's going to be a little bit off compared to what it is at the top of the box here. Definitely pulling some heat. Another thing is too, we can double check our expansion valve. Before you saw it was all an entire block of ice. We'll move this and we'll take a peek at what it looks like now. I don't know if you can see. No frost. Okay, my pressures are really good. We're just a hair above 150, or a hair below 20, and my temperature is below 40 degrees. So this should shut off. To work these, I'll cancel the alarm here. That says sensor failure. That's the discharge line. The temperature sensor is a little funky on this unit, but it works without it, and they don't want to replace it. So 0, actually 0, A, 1 is your code. SPH is set point high, so your refrigeration will turn off on that. I'll actually turn it up to 39 degrees, so it will turn on at 39 degrees. Set point low is how low it'll go, 34.3. I'll actually turn it up to 35. I can't get it exactly 35, so 35.2. Basically, we want anywhere between 33 degrees and 40 degrees. I don't like to set it too low, otherwise it tends to freeze up. Clock time. What time is it? It is 3 o'clock. 3:34. So And this one here is the date. I can't remember if this is, yeah, so this is year, date. These are the defrost lockouts that you can set, room offset, and the rest we don't need because this is a cooler. So let it go and we'll flash back to its temperature and we'll see what it's at now. .2 and it just shut off. So we're good to go. Job complete. Take off the gauges, put the caps on the ports, right up a slip.